today we're going to finish 3-5. We're going to start through 6. We are finding roots of polynomial equations, which we did on Monday this week. We did in our last section, the 3.5. Do you guys remember how we were finding roots earlier? Yeah, we did factoring. And what else?
Graphs.
Yes, and we did graphs. And in particular on the graphs, we were looking at the what? Yep, the x-intercepts, and there were a couple special things that we learned about the x-intercepts, right? Yes. Does it bend as it crosses? Does it do the touchback? Because those indicate what? Yeah, the multiplicity, right? So there are multiplicities of roots that contribute to the number of roots that a polynomial has. And today we're going to talk about something called the rational root theorem. And that can help us solve polynomial equations. We'll go over that. And then it says we're going to identify all roots of polynomial equations. That means we can find real roots and also what type? What are the other type of roots we have? Yeah, we're going to start putting in those imaginary roots in there. So the first thing we're going to learn about is a theorem called the rational root theorem. Okay, so in math, you guys have learned about different number sets, right? There's the natural numbers, which are the counting numbers. We have integers. Are those things ringing a bell? We had to classify numbers. Like, what are the integers?
Oh, 1.
1 is an integer.
Oh.
What else? Yes, any positive whole number is an integer. What else? Any negative whole number. Yep, and then integers are just positive or negative whole numbers and 0. Okay, and then we have rational numbers and irrational numbers. Do any of you remember the definition for that? What makes rational or irrational? Usually people remember irrational.
Is irrational like decimal?
Yes, but it has to, there's something special. There's some stipulations.
It can't be put into a fraction.
Yeah, so it can't be put into a fraction. And it will never end, and it will never repeat itself. Okay, so like 1/3 is a decimal that never ends, but it keeps repeating, right? Because it's 0.333333. Okay, and then so any rational, yeah, so pi would be what type? Irrational. There's some radicals that are irrational, like the square root of 2. That's a very famous irrational number along with pi. But if they are rational, they can be written as a fraction, p over q. P has to be a factor of the constant term, and then q is a factor of the leading coefficient. So we're going to do a couple of examples of this together. Again, this is going to be the possible roots. So that's a little bit different than the actual roots. Okay, but we're going to do this part together. All right, so our first example is x squared, or x cubed, minus 2x squared, plus 6, and then equals 0. Okay, so what we would do for your P over Q is we would find the constant term, which is going to be 6, and then we're going to list all the factors of that on top. So that's your value of P. So for 6, the factors are just what goes into it evenly. So 1 goes into 6 evenly, 2 goes into it, 3 goes into it, and 6 goes into it. Now you do have to put the plus or minus first, because both the positive and the negatives are going to be factors. And then the leading coefficient, if you don't see the number, what is the ALCO? 1. Okay, so it's just plus or minus 1 here. Then you divide them. So in this case, you would divide 1 by 1. It would be plus or minus 1. 2 divided by 1 is going to be plus or minus 2. Plus or minus 3 divided by 1 is the plus or minus 3. And then the 6. So what this does is it generates a list for you of the possible rational roots. These are the possible rational roots. Okay, and what that means is if you were trying to solve this for x, if you were trying to find the zeros and you got 5, 5 is not on the possible rational roots list. Okay, so that would be incorrect. If it's a rational root, it should be on this list. Okay? Alright, so I'm going to have you guys try number 2. So we have 2x to the 4th minus 3 equals 0. We're going to do our p over q. Okay, so we generate the list for the top, the list for the bottom. And then we'll do the simplifying together. Alright, Maya, what are my factors of 3? Yeah? So it wouldn't be 2, because 2 wouldn't go into it evenly. Yes, good. So plus minus 1 and plus or minus 3. Okay, and so this is our constant term, the negative 3. And then here's my leading coefficient. Alright, and then Aurora, what are my factors going to be for 2? So what goes into 2 evenly? 1, yep, so plus or minus 1. And what's the only other thing? And 2, so plus or minus 2. Okay, now when you do the dividing, the first thing we're going to do is divide by 1. So plus or minus 1 divided by plus or minus 1 is plus or minus 1. Plus or minus 3 divided by 1 is just plus or minus 3. But now we have the 2 on the bottom. So plus or minus 1 divided by plus or minus 2 is plus or minus 1/2. And then 3 over 2 is going to be plus or minus 3 over 2. Okay, and then so these are your possible rational roots. So again, if the solution to this is a rational root, it will be on this list. Okay, we're also going to use this a little bit later to help us solve equations.
Can you explain one more time how you got the possible rational roots?
This part or the final one? So what you're going to do is divide. So you take everything on the top and divide it by each number on the bottom, but you're going to do them separately. So I think of this as 1 divided by 1, and then I put the plus or minus in front. 3 divided by 1 is 3, so I have the plus or minus 3. And then do the same thing with the 2. So 1 over 2 is 1/2. The 3 over 2 is 3/2. And then you're just going to keep your plus or minus. And we are going to do some more practice with this as well. So your irrational root theorem is similar to something we did earlier in chapter 2. The irrational root theorem, so not rational but irrational, says if you have a plus b root c if that's a root of the polynomial, then its conjugate, you guys remember that word? Okay, then its conjugate is also a root. Okay, the conjugate of a plus b root c would be a, you guys remember? Minus, just a minus b root c. Okay, so if a plus b root c is a root, then a minus b root c is a root. So we're going to do this with some actual numerical examples. So let's say we had 2 plus root 3 is a root, then you tell me what else is a root. Yeah, sorry, I meant, I did say you tell me. You write it down. Okay, so 2 plus root 3, if that's a root, what else has to be a root? And then I want you to think about why this makes sense. Kate and G, tell me what the first one is. What's the conjugate of 2 plus root 3? Good. 2 minus root 3. All right. Danny, what'd you get for this one?
1 plus 2.
All right. Awesome. Okay. So, any of you think you can tell me why this makes sense, that they come in pairs like this? Mm-hmm.
Because if they're integers, then they can be both positive and negative, and then vice versa.
So, there is something about the positive and the negative, but not with the integer part. Think you know?
Is it when you multiply them by each other, they're both negative?
No, but that would happen. If you multiply it by its conjugate, do you know what happens? The square roots are going to cancel out, like on the, if you had a fraction, the square roots would cancel out. Yeah, Ashay, you know why? They come in pairs?
Because they're plus and minus.
When you do what?
When you divide.
No.
When you
When you take the square root, right? Okay, so the square roots, when you're solving, they have to come in pairs, right? Square roots come in pairs because when you take the square root, the plus or minus is in front. That's why if you have like the plus root 3, it's the minus root 3. Okay? And then if it's the minus 2 root 5, it's the plus 2 root 5. Because see how the integer part here doesn't change? Like the positive 1 is still a positive 1. The 2 is still a positive 2. The only thing that's going to change is what's in front of the radical. Okay, so the square roots come in pairs because you have that plus or minus there. Now the first example that we're doing is telling us to identify all of the real roots. Okay, so when they say that you're finding the real roots, that means that you're finding the what? They can be rational. They don't have to be. But where do all the real roots live? No, because it could be negative. Negative 1 is real.
Okay, positive.
Yeah, there's no imaginary. But where can you find all the real ones? Yes, on the x-axis, right, on the graph. So when you're finding the real roots, you are finding the x-intercepts. Okay, and those are the same thing as the zeros. But they all live in the graph, right? They all live on the x-axis of the graph. Okay, so let's find all the real roots of 2x cubed minus 9x squared plus 2 equals 0. And we're going to have a little bit of help today from the rational root theorem. And you'll see too, if you look in your book, they list things out by steps as well, and they will tell you to do the rational root theorem first to identify those possible roots. As we start to practice this, we'll talk about shortcuts, okay? But for right now, we're going to do the rational root theorem. So we're going to do the P over Q. Okay, so remember on top, that's where you're going to put factors of the constant. And then on the bottom is going to be factors of the leading coefficient. But in this case, what is the constant? 2. So your constant is 2. I know, there's not even a, oh, you were thinking. And then the leading coefficient is also 2. So guess what? You have plus or minus 1 and 2, and then plus or minus 1 and 2. So the constant is 2, leading coefficient is 2, but now we get to divide. So when you divide, let's start with 1 and then over the 1. So 1 over 1 is going to be 1, 2 over 1, 2, okay? And then with the 2, 1 over 2 is 1/2. What's 2 over 2? Yeah, so if you already have it on your list, you don't have to write it twice. Okay, so when you have two numbers on the bottom, the dividing process, top by 1, and then top by 2, top by 2. You do not have to have repeats. Okay, so if it simplifies to something you already have, you're good. So 2 over 2 simplifies to 1. Okay, good. So now what we're going to do is we are going to go and we're going to look for those x-intercepts. Okay, this says if you don't have a graphing calculator, you can guess and check. Really, I want to take that off there because you all have a graphing calculator now. And if for some reason yours is dead at home, you could always use Desmos or another online graphing calculator. Okay, so what we're going to do is we're going to look at the x-intercepts. We're going to see if we can find them on the graph. And then we're going to talk about how we can verify them. So I have 2x to the third minus 9x squared plus 2. Okay, so we're just putting in that polynomial. I'm just going to make sure that I have the standard. Okay, so when I'm looking at that, at what it's crossing through, okay, it looks like it's close to 4, but it's definitely not 4. 4 isn't even on my list. If I use my list, what are 1 or 2 x-intercepts that look possible? Yeah, it looks like what? Okay, anything else? Yeah, to me it also looks like, doesn't it also look like negative 1/2 is possible?
Oh.
Doesn't it look like both of those are possible? Okay, so what we're going to do is we're going to test those. Okay, so we're going to test to see if there's a 0 using a good buddy of ours. Synthetic division.
Okay.
Yeah, we like synthetic division, right? Yeah. And really, you could guess and check like with these, but that just takes so much time. And now that we have our graphing calculators, we don't have to worry about it. Okay, so let's test our possible roots. Okay, so we're testing those from the x-intercepts in step 2. Okay, so we're going to test those that look possible from step 2 using synthetic division. Okay, and then how do you know if the number is a 0 using synthetic division? Yeah, so if the remainder equals 0, in the synthetic division. We'll just abbreviate. Right? So if the remainder is 0 when you're doing the synthetic division. Okay? And then I'm also going to put the original problem up there. So remember that the original problem is 2x cubed. Thank you. Plus 2 equals 0. So why do I want to write that there if we're doing synthetic division? What's your first step of synthetic division?
Oh.
Uh-huh. You take the what?
Yeah, you take the coefficient.
Yeah, you take the coefficients, okay? And we do have to be careful. We got to make sure if there's a placeholder that we put it in there. Okay, so Luke, what are my coefficients going to be?
2,
Mm-hmm.
-9,
Yeah?
0.
Good. Okay, so I did have to put a placeholder in there for the x. Great. Okay, and the first one we're going to try, so the two that we found were -1/2 and 1/2. So we're going to try the -1/2 first. We'll do synthetic division together, okay? Remember, this can go pretty quickly. You're dividing by -2. So 2 divided by -2 is... Guys, I just said this can go pretty quickly. Come on now. Okay, so -9 plus 1 is -10. Divide that by -2. 5. 0 plus 5. 5. And then we're going to leave this as -5/2. You can think of it as -2.5 because then you can add that in your head, right? 2 minus 2.5 is -1/2 or -0.5. Okay, so is this a 0? Nope. Okay, so since r does not equal 0, that means -1/2 is not a 0. Okay, but I did want to show you how you can verify that. So let's try 1/2. So 1/2 also, positive 1/2 also look like that could be a 0. So I'm going to use the same coefficients. The process is really similar. Well, it's the exact same, except for the negative. So 2 divided by 2 is 1. -9 plus 1 is -8. Divide by 2, I get -4. -4 plus 0 is -4. Divide by 2 is -2. And yay, I do get a 0 there. So what this means is 1/2 is a 0. So 1/2 is one of our possible answers. Okay, so what this does is when you do synthetic division, remember this creates a polynomial. This would be x, or the number, the x squared. So really what we have here is this polynomial, 2x squared minus 8x minus 4. Okay, this is great because this is a quadratic trinomial. Okay, and I said solve the quadratic trinomial. Well, let's talk about what ways that we've learned to solve one. Oh, actually, before we do that, I'll show you one other thing. So remember how it looked like -1/2 was a 0? You could also zoom in sometimes, and it might clarify it. Let's see if this one does. So if I go to zoom and then 2, you'll see like a faint blinking, and if you press enter, it'll kind of go in there. Yeah, so this one does look like it's really, really close to -1/2. So that's definitely something we want to check with synthetic division. Okay, but as some of these get closer and you're not sure if they go through one of the values, the zoom in feature is going to be really helpful. Okay, so what ways have we learned to solve a trinomial? What are some of the ways? Yeah, factoring. Okay, and factoring is great. Okay, the only thing is sometimes they won't always factor. So that is a drawback, because sometimes it won't always factor. Really, how did we solve on Monday. We solved by looking at what?
Yeah, right.
Yeah, the graph. So graphing is great. But when you're graphing, okay, just like we saw here, this looked like it was negative 1/2, but it's not. It's another value. It's going to be a decimal value, right? So kind of the drawback of graphing is you aren't going to be able to graph and find the exact values. So it's not always possible to find exact values. For example, you could have a radical as one of your roots, okay? And the graphing is just going to give you a decimal. It's not going to give you that exact value, and that's what we want, are those exact values. Okay? There's two more. One has to do with the shape.
Pascal's triangle.
No, but we did use that. That is relevant to our course. Yeah, shape. Yeah.
So this is one of the ways
Okay.
for graphing,
Yeah.
instead of doing quadratic division,
Mhm.
just put the 0 and then be able to tell what it was.
It's my idea.
Yes, you could. You could. And then if it was like a decimal, you would know that wasn't. You remember now? What?
The difference of two squares.
No, but it's the right shape. No, completing the square.
Oh, we basically got it. Because we.
Sweet. Completing the square, and then there's one more way. This is the way we're going to use, so. No. Something that we did in the last chapter. Something we did in 2.6.
Wait. It's
What type of equation is it?
quadratic.
So what is there to solve a quadratic?
Quadratic.
No? Yeah, the quadratic formula! Because the grouping would be part of the factoring. Okay, so the quadratic formula is something that we will be using over and over and over. So opposite of b plus or minus b squared minus 4ac divided by 2a. Okay? And really, you could try to do those other methods. That would be fine. If you have a quadratic trinomial and it is factorable, I think factoring can be quicker than doing the quadratic formula sometimes. It just depends on what you had. But if you did try to factor this, what would you do first? Yes. What's the GCF? 2. So if you took out the 2, it would be x squared minus 4x minus 2. Okay, good. That makes that a little more manageable for us. So I know it has to start with x and x. And then what I'd ask myself is, what multiplies to negative 2 that adds to negative 4? Well, the only things that multiply to 2 are 2 and 1. So the biggest value I could get would be 3, and that's too small. So factoring, it's not factorable. Okay, it's not going to work. But that's where the quadratic formula comes in. Okay, so that's why we do use the quadratic formula. It's always going to work, so you don't have to try to factor it. You don't have to do that. Okay, so you can use your A value is 2, your B value is negative 8, your C value is negative 4. And then we're going to plug it in and see if we remember how to simplify. So x equals the opposite of b. Okay, I'm going to let you plug in the rest. And then I want you to simplify what's underneath the radical. when you guys are writing out the b squared, okay, because the b value is negative, if you're writing that part out, then I do want you to put the negative 8 in parentheses squared, because it means something else with the negative on the outside. What I generally do is I square it, and then I plug it in, because I know this is always going to be positive. So 64 is my b squared minus 4ac. Now pay attention to your signs here. You have negative 4 times a negative 4, which is going to be positive. So negative 4 times negative 4 is 16. 16 times 2 is 32. And then when you add it, yep. So you have 8 plus or minus. So this will be 64 plus 32 over 4. Which will be 8 plus or minus the square root of 96 over 4. So now let's simplify the square root of 96. Okay, when you guys are doing this, are you trying to find the biggest perfect square? Are you doing factor tree? A little bit of both? Okay, so what I would start is taking 96 and dividing it by what? 2. No, don't do 2. Because 2 is not a perfect square. Okay, but if 4 is a perfect square, right? So you can always start with 4. Unless you notice it's an even number, then you don't. Okay, and then, okay, 4 goes into it, great. But 24, what's the perfect square in 24? 4. So there's a bigger number that goes in there. What's 4 times 4? Okay, so let's see if 16 goes in there. Yay! It does, 6 times. So that means the square root of 96 is the same thing as the square root of 16 times the square root of 6. Okay, and I do like the little sidebar like this, so I just don't have to keep writing that out. And then what does that simplify to?
4.
Yep, 4 root 6. And if you're doing this on a test and you're not feeling confident about your simplifying ability, you can always double check to make sure it's equivalent. So the square root of 96 will give you this decimal, and then 4 root 6 should give you the same thing. Okay, so you can make sure that these are equivalent. The only thing is it won't tell you if you left a perfect square in there. Okay, because if you just did the 4, it's 4 times 24, right? So if you did 2 root 24, it would still be the same. It just wouldn't alert you that you have to take out something else. Okay, but that is a good thing to double check. All right, so now our last step of simplifying, this is going to be 8 plus or minus 4 root 6. And then remember, you divide both of these by 4. So you have to divide both of them by 4 to get your final answer. So 8 divided by 4 is 2. 4 divided by 4, those are going to cancel, so you're just left with root 6. Okay, so what we're going to do is we're going to list the zeros. And remember that the number of zeros should be the same as what? The degree. And remember, the degree is the same thing as the what? Yes, good. Okay, so the degree is the highest exponent, so remember that. Okay, so this means this polynomial has how many zeros? Nope. So the original, this is our original, right?
Oh, 3.
Yeah, so there'll be 3 total. So we just found 2 of them from the quadratic. But remember, the first one we found that we verified with synthetic division was 1/2. So I have 1/2 is one of them. I have 2 plus root 6, and I have 2 minus root 6. That is where the 3 come from. Okay, and I do like to write them out when we're doing this, since we do want to make sure that the 3 corresponds with the 3. All right, let's try part B, which is 2x cubed minus 3x squared minus 10x minus 4. Okay, so we did a lot in that first problem. We're condensing it down now. We've explained those steps. Now we're just going to go through those steps. So I'm going to give you time to do this. I'm just going to help you get started. So you're going to do the P over Q for step 1. In step 2, you're going to find the x-intercept on the graph. And then you are going to verify that with synthetic division. Okay, so I want you to see if you can do the 1, 2, 3. Okay, the 1, 2, 3 for part B. Let's see how the P over Q went. So for the top number, we have the factors of 4. So you should have 1, 2, and 4. And then the factors of 2 are 1 and 2, so we're going to divide those. So we already know this is always going to have a 1 on it. So all of the values on top, when you divide them by 1, are going to give you the same values. Now we're going to divide by 2. So 1 divided by 2 is 1/2. And then 2 divided by 2 simplifies to 1. 4 divided by 2 simplifies to 2. So here is our list of possible rational zeros. So what we're going to do is we're going to take that list, and then when we graph this, we're going to be looking to see which one of these on the list corresponds to an x-intercept value. So minus 10x minus 4. And if it is the fraction value, oh, I was going to say this can be a little bit hard to see, but remember I zoomed in on the last one. I'm going to go back to standard, so I'm going to go to zoom, and then 6 is the standard. You're 10 by 10. Okay, and then I can see, oh, it looks really close to 3, but it's not like going directly through it. And 3 isn't even on our list, so that's probably not going to happen. But let's look and see what's going on here. So I'm going to go to second, zoom, or sorry, not second, just go to zoom, and then zoom in is 2. And then a little cursor will appear and start blinking, like mine is right at the origin. So I'm going to press enter. And you can move that depending on what you want to see. But I can see this is close to -1, but this isn't, like I don't have anything on my list in that range, but this looks like negative 1/2 here. So I'm gonna try that x-intercept on my graph. And again, that's on my list. Okay, that's how I know it's 1/2 and not 1/3. Okay, so that's what we're gonna use with our synthetic division. Okay, do you guys have questions for me about that? Were you guys able to find the negative 1/2?
How do you like change the window again? Like, because mine is like zoomed in a lot, so I can't
Oh,
see it.
so when I did the zoom and like zoom in, I went to the origin, but you can also change your window. So this just zoomed it in from negative 2.5 to positive 2.5. You could just do negative 3 to 3. Go by ones. Negative 3 to 3, go by ones, and that will give you a window. So you're basically just trying to get really close to the origin to see what's happening close to that. And then we're going to verify this with synthetic division still. So my coefficients would be 2, negative 3, negative 10, negative 4. Don't forget the negatives. Okay, you won't be able to find if it's a 0 or not if you don't include the correct signs. So I have negative 1/2 that I'm testing. So I drop down the 2. 2 divided by negative 2 is negative 1, which will be negative 4. Divided by negative 2 is positive 2. Add straight down. Negative 8 divided by negative 2 is positive 4. Yay! I got the remainder of 0, which means what you just have done is found that negative 1/2 is a 0. So this is going to be part of your final answer, that negative 1/2 is a 0. Now we're left with this quadratic. So I have the number, I have the x, I have the x squared. So your fourth step is to set the quadratic equal to 0 and solve. Okay, and again, there are multiple ways to solve. If you want to just do the quadratic formula, you can do that. Another little hint I can give you that we could have done with the last one as well, because the last one we had a lot to simplify, right? So if I were to take 2x squared minus 4x minus 8 equals 0, okay, if I'm going to solve this, what can I do? My first step. I can simplify this. What goes into all of them? Yeah, so if you wanted, you can divide both sides by 2. Okay, you can never divide by like a variable because that's what you're solving for, but you can simplify this. So if you divide by 2, you have x squared minus 2x minus 4 equals 0. Now you can solve that. It's just going to make your process a little bit simpler. I'm going to continue this at the top. Again, if you've already started this with these numbers, you are still going to get the same final answer. It just means that you're going to have to simplify a little bit more, which is fine. Okay, so if I have x squared minus 2x minus 4 equals 0, my a is 1, my b is negative 2, my c is negative 4. Okay, so x is going to be the opposite of b, plus or minus b squared, which is 4, minus 4, a, c, divided by 2a. Alright, so then we have x equals 2 plus or minus, and then underneath here, a negative times a negative is a positive. So 4 plus 16 is going to be 20, divided by 2. What's the perfect square that goes into 20? Yeah, so this is root 4 times root 5, which is 2 root 5. That's you. So then 2 plus or minus 2 root 5. And then remember, you divide both of these by the bottom number. So this divided by 2, you're going to divide both of them by 2. Okay, so if you have 2 terms, you divide each term by the bottom number. So 2 divided by 2 is 1. 2 divided by 2, that would be 1. 1 root 5 is just root 5. There you go. And then your last step is just to list all of your zeros. So we're going to put all of them together. And there should be a total of how many? 3, because that's your degree, that's your highest exponent. So we have negative 1/2, 1 plus root 5, 1 minus root 5, okay, and you should have a total of 3 zeros. So we just found real zeros, but remember earlier we talked about how you could have what type of zeros? Imaginary. So that's what we're going to get into next.